All right, welcome back. So let's kind of look at a specific case of the chain rule. And we're going to call this the general power rule. So this is really just a special case of the chain rule, but it shows up enough where it's going to be helpful to just have a special name for it. All right, so let's read what the general power rule says. Let u be any differentiable function, then the derivative of u of x all raised to the power r. And before we go any further, before we read this, this is a composite function. There's an inner function, u of x, and an outer function, which is the power function. So let's just quickly identify. We have an outer function in this formula here, which is raised to the power r, and our inner function is u of x. So we have a power function and we have an inner function, and the power function is the outer part here. All right, so how do we differentiate this composite function? Well, chain rule. So what would chain rule look like in this case? Well, it says we want to differentiate the outer function. So the outer function is just power rule. So it's just a power function, so we would use power rule. So bring down the r, that's what we see. We keep our inner function the same, so u of x is still going to be inside this power function, and then we subtract 1 from the exponent. So this whole first piece here, this is the derivative of our outer function. It's the derivative of the power function part with our inner function plugged in. So if we go back to our chain rule, that first part we're looking at is the derivative of the outer function with the inner function plugged in. So what have we done here? Basically the same steps as our power rule. So kind of think of this as like a process. Step 1, you bring down the exponent. Not too bad. Step 2, normally if it was just power rule, what would we do? We'd bring down the exponent, we keep our variable the same. Now for a general power function, we bring down our exponent, we keep the terms inside the parentheses the same. And then finally, going along with the power rule, brought down our exponent, we've kept the terms inside the same, and now we subtract 1 from the exponent. Just like we'd normally do with power rule. All right, so this differentiates just the outer function piece. So we've differentiated the outer function, but we know with chain rule, once we've differentiated our outer function and we've kept our inner function the same, then we need to multiply that result by the derivative of the inner function. So that's what we're seeing next, right over here. We multiply that result by the derivative of our inner function. All right, so how does this look in practice? So let's look at that one function we've seen before. This was a composite function which we broke down and looked at the two pieces. And we saw, when we did this, we saw the inner function was this polynomial, x to the 4th plus 9x plus 3. And the outer function was raised to the power 8. And so what we're going to do is to calculate this derivative, we're using the general power rule. So how it actually looks is we start by differentiating the outer function, and we kind of work our way in. So we're going to start differentiating this outer function raised to the power 8. So what do? Bring down the 8, put it in front. Keep the terms in inside the parentheses exactly the same, so don't change these. So we're still going to have an x to the 4th plus 9x plus 3. And then this was an 8. We subtract 1 from the exponent just like usual. So that should feel pretty similar to our good old-fashioned power rule up here. Bring down the exponent, keep the terms inside the same, subtract 1 from the exponent to get our new one. That's what we did here. Brought the 8 down, kept everything the same, no changes. X to the 4th plus 9x plus 3, x to the 4th plus 9x plus 3, and then we subtract 1 from that big exponent. Now that's not the end of the story. Then we take those terms that are inside, the x to the 4th plus 9x plus 3, and we multiply by their derivative. So we're going to differentiate now the inner function. So what's the derivative of x to the 4th plus 9x plus 3? That's what we're doing right here. This u prime, that's us actually differentiating the inner function. And so if we calculate that, we're done with this first part. That's all taken care of. We've already gone through the differentiation there. And then let's differentiate our inner function. So derivative of x to the 4th is 4x cubed. Derivative of 9x is 9. And derivative of 3, just 0. So there we go. We have our derivative. And the way we differentiated this was kind of with this special power rule, which is really just a special case of the chain rule. So it was the derivative of our outer function times the derivative of our inner function. All right. In the next video, we'll see another special case, depending on what the outer function is. So we'll see you there.